Hello learners, welcome back to Education Program Online with me, Teacher Christine, taking you in mathematics for Senior 3 and Senior 4. So my dear learners, we are still on our very topic of real functions and limits. Under it, we are specifically looking at what we call the composite functions. In the previous lesson, we had introduced what a composite function, and we did not complete it. So we are going ahead by looking at example 2 under composite functions. Example 2. So our question is, given that function x equals to x plus 3 and gx equals to x squared minus 1. Then they said find A, we have f gx, and then we have b g f of x, and then we have c, which is f g of 2. So remember, in our first example under composite functions, we said composite functions, these are functions which are made up of many different functions, meaning that it is more than one. And we looked at example on a simple, what we call the linear equation. How do we find the composite functions if the functions are of linear equations? And then I remember you saw what we did it and how we arrived to the answer. And now when we look at the example number 2, it is containing or consisting of a linear equation and a quadratic equation. So function f is for a linear equation, and then g is for a quadratic equation. So in this case, if they ask you to find the composite function of this kind of functions, what do? You look at the equation. Remember the other on our introduction we said the order of these functions that make up what we call a composite must be taken very serious. So meaning that you must follow the order for you to maintain the relation between or more than one function. So you follow the order, who comes first, who comes second, or who comes next. So this is what you are supposed to do. So let us look at how do we get the solutions of this kind of equation fg. It means that if they ask you fg, it means you are g in x, g in x. So for you to get g in x, then you simply say I will have fg of x equals to f outside g inside. That is the simple way you can master this. Then now it means that the whole function g must be inside the bracket, and then the function for f must be outside the bracket. So now when you look at our function f here, we take the variable, which is the x, because we are looking at the relation of the variables. So you take the variable, which is x. So what is the coefficient of x here is 1. So we simply substitute where there is f, we substitute it with the 1. So you say 1, and then you open bracket, you write the whole function of g, which is x squared minus what? Minus 1. Remember that the whole of function f must be outside. So we have a constant 3 here. So this constant 3 will be outside the bracket of this side. Then now you, after substituting it like that, then you can now open the bracket by saying, when I multiply 1 times x square, I will get x square. And then when I multiply 1 times negative 1, I will get negative 1. And then plus 3. You are not going to multiply because of this operation plus. So you are not going to multiply 3 to open the bracket. Then now from here, you will simply say, therefore, fg of x will now be negative 1 plus 3, because these are known values. So it will give us positive 2. So our answer will be x square plus what? Plus 2 for this case. This is our answer. So learners, what do you note from here? You note that you find that the answer has remained in unknown value, because from your question here, they have given us x here, which is unknown. We don't know the value of x. Therefore, your answer also should remain in unknown form. And then now you come to part B. So when we come to part B, so part B is gf of x. So gf of x means that we are going to have g out, and then f will be inside the bracket. So you simply say equals to g out and then f inside. So this is the only way you can easily be able to work out this kind of questions. Then now you come and say, what is g? G, which is supposed to be out. Look here. The function g is, the coefficient is 1. But because of this power, it means we are going to square all the values of what? Of x, of f. So we substitute. We are not going to put anything there. We simply say, since g is in a square, the coefficient, we shall fill the function f, which will be, the function f is given as x plus 3. So we say square it. And then now the remaining constant will be outside here. So that is how you substitute if it is in a quadratic form. Then now from here, what does this mean? It means you expand this given equation. So you expand it by saying, I will have x plus 3 times x plus 3, and then minus 1. So when we multiply this, we say x times x, it will give us x square. And then x times 3, we get plus 3x. And then 3 times x, we get plus 3x. And then 3 times 3, we get plus 9. So now from here, you will find that we have the like terms here. 3x and 3x will give us 6x. So we shall have x square plus now 6x, and then remember there is this minus 1 here. So then plus what? 9 minus 1, we get 8. Then now you simply say, therefore, g f x equals to x square plus 6x plus 8 is our answer. So still it will have to remain in unknown, because here they have not given us the value of x. So learners, that is how you deal with the quadratic functions in composite functions. Now when we come to part C, so part C, they have given us the value of x. So part C, you say fx of 2. So before you go to substitute x, you need to first to deal with this problem here, the FG. So the FG, how do you deal it? You will simply say, I will first get FG, and FG of X will automatically give me F out and then G in. So when we substitute this, we get the coefficient of, you only look at the coefficient, we don't repeat, because you look at that function f contains a variable which is x, and function g also contains a variable of x. So x and x are the same, so we only take the coefficients. Then we have now here, our coefficient here will be 1, and then you open the bracket, we have g, which is x square, the whole of g, and then minus what? Minus 1. And then plus that one of f, which is plus 3. So that is your expression. Then now you come down and say, if fg is 2, meaning that x is 2, what will happen to this? That is now at this level, this is where you are going to do what? You are going to substitute the value of x. So you will have 1 into 2, which is x square, minus what? Minus 1, close the bracket, plus 3. Plus 3. Then now you will simplify first what is inside before you open the bracket. So 2 square will give us 4. So you will have 1 into 4 minus 1, and then plus 3. So what is here is going to be 3. So 1 times 3 automatically will give us 1 into 3 plus what? Plus 3. So this will give us, when you open the bracket at this level, we get 3 plus 3, which will give us what? 6. Then now you come and say, therefore, fg of 2 equals to 6. That is how you simply substitute to get your answer. I repeat, if the value of x is given, what you do, you first express the functions. Express the functions as a composite functions, and then after that is when you now substitute the value of x, just like what we have done. So learners, that is how you simply handle questions of that kind. So we are just completing the part of the composite function which remain, and therefore I want you to take these questions under composite function. You take these questions as your exercise. Meanwhile, we shall continue from with another concept. So you say, if fx equals to 2x minus 5 and g x equals to 3x, equals to 3x plus 1. Find a, we have a f g x, b g f x, and then c we have f g negative 1, and then d we have gf of 0. So in your final exams, you will never miss these composite functions, and this is how they just set their questions. So they will never do what? They will never change anything from it. It is the easiest topic, even in the sub-topic that is for you to pass when you get the question in your exams, because the arrangement will be constant. They will keep on changing f, g, or gf, and then part 2 says if given that g x equals to x squared plus 2x, and then plus 3, and h of x equals to 2x plus 1. Find a g h of x. B, we have h g 2, and then C, we have h g of x. So learners, you take those questions as your exercise. You'll do them in your free time. And then now, this actually marks the end of how to calculate the composite functions. So we are moving ahead by looking at how do we find what we call the inverse of a composite function. The inverse of a composite function. Inverse of composite functions. Composite functions. So you find that in some books, even they do what? Or in other places, they don't even give you the inverse of a composite function. But it's very important, because you, in case you come across it in the exam, when you don't know how to handle it, how to deal with it, you will not be able to do what? To get the correct answer. So when we talk of inverse, I remember when it is not a new term to you, because we looked at the inverse of a function alone. But now here we are looking at the inverse of a composite function. Inverse of a function that is a singular function. But in this case, you see where the a functions is doubled or moved more than one. So we are not going to, we are just going straight away to look at it, how do we get the inverse of a composite functions. So look at example 1. They say given that g equals to gx equals to x minus 2, and fx equals to 3x minus 1. And then they say find a g raised to negative 1 of x. And then B, we have g raised to 1 of x. And then C, we have f raised to 1 of x. So if we are given to find the inverse, remember we said the sign of inverse or the symbol of inverse is a variable raised by a negative 1. So this one automatically, even if they don't write there the word inverse, once you see this in functions, just know that this is the inverse of a function. So part A, they are asking us to find the inverse of g. So we look at the inverse of g. We said the inverse simply means to interchange, the interchange or the opposite, the interchanging of signs. Now, when we come to our solution here, we say A is given as G, X is given as X minus 2. That is the linear equation. Now, if we are to get the inverse of this, remember that for us to look at the interchanging of the variables, here we have y, x, and here we have x, we don't have y. And we said that in a relation of functions, we look at specifically x and y. Now, where there is gx, we are going to substitute with the y. And then we shall have our equation as y equals to x minus 2. And now from there, that is now where you are going to interchange. So if you are to interchange, you look at here as a negative, and here is a variable. So what do? You simply make x a subject. And if you make x a subject, it means you are going to eliminate the negative 2 from the other side, and it comes to this side of y, so that you leave x alone. So you will have y, when x negative 2 crosses equal signs, it changes to a positive 2, equals to what? Equals to x. Therefore, you simply now say x equals to y plus 2. So, learners, when you reach to this point, remember in the previous lesson we said, once you reach to get the value of y, x alone, it is now at that point where you will now find the inverse. So, and when you are finding the inverse, what happened? You are going to interchange the y, or substitute y with the x. Then now you come and say, therefore the inverse now here will now be, you rewrite this outcome by saying x will now be substituted by y. Y is going to be substituted by x and then plus 2. So this is the inverse of that function g. So after that, then you can go to part B. So for part B, you'll find that here they have given us already two functions, two composite functions, that is g and the inverse of g. So what do? You first give expression of this before you do you get the inverse. So the expression of this is g, meaning that you are going to have g raised to 1 of x is the same as saying g out and then the inverse of g inside the bracket. As simple as that. Then now from there you substitute. What is the coefficient of g? So you come to the g, the function of g here. So the coefficient is 1. So you will have 1 inside the whole equation or of function of inverse g. So the function of inverse g is given as x plus 2. So you are going to write x plus 2 inside here. Then you close the bracket, and then remember that in g, the whole of g should be outside here. So you will have your expression in that nature. Then now from here, you will open now the bracket. You say 1 times x, I will get x. 1 times 2, you get 2. And then minus 2. Therefore, your answer will only remain as x. Then now you come and say, therefore, g inverse g of x will be x as your answer. So learners, that is how you, if in case you are asked to get the inverse of a function times the inverse of a function. So that is what you are supposed to do. And then we look at the part C. But now with the part C, as long as you have understood how to get the inverse of G, then you can easily also get the inverse of F. So part C, you say we have F raised to 1 x. So this one is the same as f of x is given as 3x minus 1. And therefore we said for us to get the expression, we change the function into y, which will give us 3x minus 1. Now in this level, we are going to do what? You are going to eliminate, you make x a subject. So if for us to make x a subject, we have to eliminate the constant from the side of x. Then we shall have x, negative 1 crosses becomes positive 1 equals to 3x. So in this form, you are now going to subdivide both sides by 3, so that you can now have x alone. So you divide both sides by 3 so that you get x alone. So x alone will give you y plus 1 over 3. So in this level is where you are going to rewrite what we call the inverse of the function. So you will now come and say, therefore, the inverse of f raised to 1 of x equals to, substitute y with the x, will give us now x plus 1 over 3 as your answer. So dear learners, that is how you just play with the inverses of a composite function. And then let us look at the last or the next example under the inverse. So they can say, given that g equals to 3x minus 11 and hx is given as x square. Then they say find a g h x and then b inverse of g, and then c we have g h of 1. So learners, if we are asked to get the values of this, or to evaluate this, you will simply know that if there are more than one, it is a composite function. And now what should I do? The order matters here. For the solution of part A, which is gh, x is the same as say it is g out and h inside. So we substitute the value of g. The value of g here, we come and look at the function g. The coefficient of x is given as 3. So where there is g, you put 3, open your bracket, the whole of h is in, which is x square, close the bracket, and then minus 11. So from here you say, open the bracket, 3 times x square, you get 3 x square, and then minus 11. So with this, because they said in x is not known, then your answer will be h of x equals to this. And then part B is the inverse of this. So our inverse, we say gx is given as 3x minus 11. And we said if we are asked to find the inverse, then we have to integrate it. You have to interchange this. Instead of gx, we say it is y. Make expression which is defined. Y equals to 3x minus 11. Then now from here you get what? You get make x a subject. So when you make x a subject, it will now give us y negative plus 11 equals to 3x x. So you divide both sides by 3x. You divide both sides by 3 so that you get x alone. So this will cancel and you'll have x equals to y plus 11 over 3. So the inverse of this, it is here where you write the inverse by getting g minus 1 of x equals to x plus 11 out of 3. So this is your answer. Now, my dear learners, with those steps or those examples that you have seen, I hope you can be able to try part C in your own free time. We have come to the end of our lesson, and I hope that you have picked something under composite function, how to deal with the composite function, how to get the inverse of a composite function. My dear learners, here we have come to the end of our lesson today, and I wish you a good day. Goodbye.